Today we will see Ohm's law in the electrical circuit. So Ohm's law is very simple algebraic relationship between the voltage, current and the resistor in the circuit. So let's say we have one voltage source which is connected to a one resistor R. So because of that the current will flow through this resistor R. So, according to the Ohm's law, at constant temperature, the electrical current flowing through a fixed linear resistor is directly proportional to the voltage applied across it, and it is inversely proportional to the resistance. So, the current which is flowing through this resistor R is directly proportional to the voltage applied across it, and it is inversely proportional to the resistance of this resistor. So now let's understand this Ohm's law by taking a water tank analogy. So let's say we have one water tank, and at the bottom of the tank we have connected one hose pipe. So in this analogy, the water in the water tank can be represented as a charge in the electrical circuits, while the level of the water in the tank or a water pressure represents the voltage in the electrical circuit. The diameter of this hose pipe represents the resistance in the circuit, and the flow of water through this hose pipe represents the current in the electrical circuit. So now let's take one example. Here we have two water tanks which contains a equal amount of water in the both the tanks, but the both the tanks have a different diameter of hose pipe. So definitely the tank which has a larger diameter hose pipe will have a more flow of water. In the second case, where the diameter of the hose pipe is small, the flow of water will be less because the water will observe a more amount of resistance through this lower diameter hose pipe. While when it flows through a larger diameter hose pipe, it feels less amount of resistance. So let's correlate it with the electrical circuit. Let's say that we have a two electrical circuit which has a same voltage sources, but the value of resistance in the both the circuit is different. In one case it is R1 and second case it is R2. And so according to the Ohm's law, the current flowing in the first circuit can be given as V divided by R1. In the second circuit it can be given as I2 is equal to V divided by R2. Now here the resistance R2 is less than R1. So the more current will flow through this second circuit as the value of resistance is less. But in the first circuit, as the value of resistance R1 is more, the less amount of current will flow. So for both these circuits, I2 will be greater than I1. Now let's take second example in which we have a two water tanks with the same diameter of hose pipe, but in the both the tanks the amount of water level is different. In the first tank we have a less amount of water, so because of that the pressure exerted at the bottom of this hose pipe will be less. So because of the less pressure the flow of water will be less. But in the second case, as it contains more amount of water, the pressure exerted at the bottom of the hose pipe will be more. So because of the more pressure, the flow of water will be more through this pipe. So now let's correlate it with the electrical circuit. So let's say we have a two electrical circuits with a different voltage sources, but both the circuit contains a same amount of resistance, that is R. So the current flowing through the first circuit I1 can be given as V1 divided by R, while in the second circuit it can be given by I2 is equal to V2 over R. Now here the voltage source V2 is greater than V1, so the more amount of current will flow through the second circuit. So we can say that for both the circuits, if V2 is greater than V1, then I2 will be greater than I1. So through this both the examples we have seen that if we keep one parameter constant, let's say if we keep voltage constant and we change the value of resistance, or if we increase the value of resistor R, then the current will reduce in the circuit. Or if we keep the resistance R constant, and if we increase or decrease the value of voltage in the circuit, then accordingly the current will increase or decrease proportionally. So now let's take a examples based on the Ohm's law. In the first circuit, we have a 1 voltage source with a 5 volt which is connected to a 10 ohm resistor. So we need to find what is the current that is flowing through this 10 ohm resistor. So the current I can be given as V divided by R. So here the voltage is 5 volt and the resistance is a 10 ohm. So the current flowing through this circuit can be given as a 0.5 ampere. Now in the second circuit, if you see, we have one 5 volt voltage source which is connected to a unknown resistor R. So we, and the current that is flowing through this circuit is given as a 2 ampere. So we need to find the what is the value of this resistance R. So we know that according to the Ohm's law, I is equal to V divided by R. So we can write R is equal to V divided by I. Now here we know the voltage, that is a 5 volt, and the current that is flowing through that circuit is a 2 ampere. So from this, the value of unknown resistance will be the 2.5 ohm. So basically this Ohm's law is a relationship between the voltage, current and the resistance. So if you know any of the two quantities, you can find the third one. So let's say you know the current and the resistance in the circuit, then voltage can be defined as V is equal to I into R. Or if we know the voltage and current in the circuit, then resistance R can be given as V divided by I, that is V divided by I. Likewise, current I can be given as V divided by R. So in the Ohm's law, if we know any of the two quantities, we can find the third one. Now, so in the last video we had seen what is power in the electrical circuits, and it is given by relationship P is equal to V into I. So according to the Ohm's law, we know that the current I can be given as V divided by R. Now let's put this into this equation. So we'll get V into V divided by R, that is a V square divided by R. So power can also be defined by V square over R. Now we know that voltage can also be written as I into R according to the Ohm's law. So this power P, that is V into I, can also be written as I R into I, that is a I square into R. So power can be defined as either product of voltage into current, or V square divided by R, or I square into R. So in this way we get a relationship between the power, voltage, current and the resistance in the circuit. So let's see this pie chart which is show the all the possible relationship between the voltage, current, power and resistor. So here if we know any of the two parameters in the circuit, let's say if we know current and power in the circuit, then we can find the remaining two parameters in the circuit. So if we know current and power, then the voltage can be defined as a P divided by R I. Likewise, the resistance R can be defined as a P divided by I square. So in this way, if we know any of the two parameters, we can find the remaining two. So let's say if we know power and resistor in the circuit, then we can find the current by under root P divided by R and the voltage that is given by under root P into R. So in this way, If we know any of the two quantities, we can find the other two. So let's take a example based on this relationship. We have a 110-volt voltage source which is connected to a unknown resistor R, and the current is given that which is flowing through that circuit is a 2 ampere. So we need to find the value of this resistor and the power dissipated across this resistor. So first of all, let's find the value of this resistance. So according to the Ohm's law, R is given by V divided by I. So here voltage is given, that is a 10 volt, and the current that is flowing through the circuit is a 2 amp. So from that we find that the value of resistance R is a 5 ohm. Now the power P, we had seen that it can be defined by a V into I. So here we know the voltage is a 10 volt and the current is a 2 ampere. The power that is dissipated across the resistor will be 20 watt. Now let's take one more example. Here we have a unknown voltage source V which is connected to a 10 ohm resistor, and the current flowing through the circuit is given I is equal to 1 ampere. So we need to find the voltage, this unknown voltage, and the power dissipated across this 10 ohm resistor. So first of all, let's find the voltage V which is given by I into R. So here we know the I is 1 ampere and the value of resistor R is a 10 ohm. So the voltage in the circuit will be the 10 volt. So the unknown voltage source has a voltage of 10 volt. Now the power P can be given by I square into R, that we already have seen. So here current is 1 ampere, that is a 1 square into R, that is a 10 ohm. So we get a 10 watt. So the power dissipated across the resistor will be the 10 watt. So using this Ohm's law, we can find the voltage, power, current and resistor in any electrical circuit if we know any of the two parameters in the electrical circuit. So I hope you understood what is Ohm's law in the electrical circuit, and using this how you can find the four different parameters in the electrical circuit.